go. There we go.
Okay, so last year we did something that we thought worked very well. We wanted it, would like to see it better attended, because we're doing it for you folks. And essentially it is a regular seminar series, okay? Mainly it's been of alumni who can give you an idea of their career path, and because now you have to start thinking about where you're going. You don't have to worry about it, but you have to start thinking about it. And so this lets you know that the path is not always straight. We've had mainly alumni and other folk. Today I'd like to introduce other folk. Dr. Valerie Rapson's been with us for 2 years. She came to us from the Dudley Observatory with an expertise in extrasolar planets and astronomy education, and she's going to tell us how she got there.
Yes, thank you. So good to be here. Basically, I'm just going to give you the story of my life for the last 15, 20-ish years. You should feel free to ask me lots of questions. Anything you want to ask is fair game about, my thoughts in college, my different career paths, the good, the bad, and the ugly. I am happy to share whatever you want to know because I want you guys to succeed in whatever career path you want. Do you have a question, Jerome?
Sure, can you just dim the light a little?
Yeah.
Good to see you.
Thank
you.
Oh, that made it worse. Oh, I don't know. People at home will still be able to see, but we'll make it work. All right. And by the way, I'm a big fan of XKCD. This is on my office door, as well as the second and third rendition of this comic. So if you haven't seen this, you should come look at my door. It's super amusing. All right, so just a little introduction about my background and where I'm from so you guys know. I grew up in Rochester, New York, so not far from here. And I had always been interested in science, technology, math, but I didn't really know what I wanted to do with my life when I was younger. I honestly didn't even understand that physics was a thing until late high school, and I decided to major in it in college. I knew I was curious about the world around me, but I didn't know that physics was studying the world around me. I just never heard of it before. So growing up, I was a big sci-fi fan. I love Star Trek. You can see the NCC 1701 in my office. It actually lights up. We can plug it in sometime and play with it. It's really cool. But the main thing that really kind of kick-started my path down the physics and astronomy world was the time that I spent with my dad delivering newspapers overnight. We weren't a very rich family. We needed to make some extra cash, and I would get up in high school and help my dad deliver newspapers. And at 1, 2 o'clock in the morning, the only thing on the radio, because this was before, phones and internet, you could stream whatever you wanted, was Coast to Coast AM. Does anybody ever listen to this before? Yeah, some of the faculty in the room have. So Coast to Coast AM with Art Bell is basically a call-in radio show. And he really liked to have conspiracy theorists call in. So there was always stuff about aliens and just various conspiracies. And I always remember telling my dad how fascinating this was to me and how I was going to go to MIT someday and figure it all out. Because I didn't believe the conspiracy theorists, but I wanted to know more about astronomy, the search for life, the possibility of aliens. And that's really what got me thinking about, a degree in this field. So I didn't end up at MIT, but I did go to a couple of different colleges. I actually started at the Florida Institute of Technology. I went there for 2 years. And then due to some family reasons, financial reasons, I can tell you that whole story another time. I ultimately came back to Rochester and graduated from the University of Rochester. So there my degree was actually a combo physics and astronomy. It's one degree put together. And we had a very unique class of students. I don't think this will ever happen again at a private institution like the U of R, but there was 7 of us, 6 of us were women, and only 1 of them was a guy. It's usually the other way around in physics, right? It's almost that way exactly in this room here. So I was very lucky to have so many other young women going through this process with me. By the way, does anybody recognize the stance in this picture? Josh might recognize it if he was here. Anybody seen this photo before? No? It's a mimic of the Harvard female computers from 1913. So we're total dorks, right? If this is never going to happen again, we had to do this. So we got our male student colleague and then one of our male professors, and we lined up like them and wore silly dresses and took pictures. So in undergrad, I had the opportunity to do a bunch of different types of research because I didn't know what I wanted to do. I didn't go in necessarily with the knowledge that I wanted to do astronomy. I started out doing some global warming research. I actually used MATLAB to design some codes that would show how aerosols would go into the air, flow around the planet, and potentially reduce global warming if we could put enough aerosols in the air to do that. But I wasn't a huge fan of that, modeling of atmospheric conditions just really wasn't my thing. So I ultimately, the next year, started working with the team of astronomers there, and I got to work with these lovely folk. Judy Pfeiffer was my technical advisor, but I also got to work with Dan Watson and, oh my goodness, name. Blanking out his name. But they're all there. They worked with the Spitzer Space Telescope, and they basically, before I got there, they designed some of the equipment that launched the cameras on the Spitzer Space Telescope. So I got to work with Spitzer data that they had, looking at young stars in particular. So that was really cool, kind of solidified my idea that I wanted to work in astronomy. Bill Forrest is his name. I knew it would come to me. Bill Forrest, Dan Watson, and Judy Pfeiffer. So I got to do some great astronomy projects with them. And so as I ended my career as an undergrad, I didn't really know what I wanted to do with my life. The U of R, unfortunately, didn't prepare me very well for a career in a sense that, all of those wonderful people were academics and they had no other experience outside of the world of academia. So they just assumed that I would go to grad school and kind of take that path. There was nobody there to help me figure out all the other types of career paths that you guys can go through as physicists and astronomers. So I didn't know what I was going to do, so I figured, why not go to grad school, right? Let's just keep going to school until I figure out what I want to do with my life. So I did apply to grad school, got waitlisted for pretty much every grad school I applied to, ultimately got into RIT, and I went there. I'll tell you that story in a second. But before I went to grad school, I was approached by one of the administrators at the U of R, and she told me that they often teach over the summer a class for 10th grade girls who are interested in science, that want to take physics, but are anxious about it because they don't think they're very good at math and science. So they go through what they call the prep program at the U of R, and they learn some physics ahead of time so that they definitely do well in their high school physics class. And the administrator said, do you want to teach it? And I was like, me? Do you want me to teach it? I had never taught anything. I was not nearly as comfortable standing in front of people as I am now. But I didn't have anything else to do over the summer except for, smaller side jobs. So I was like, yeah, sure, why not? I'll give it a shot. So that is really the moment that kind of made me realize what I want to do in my life. So moral of the story here, take chances, even if they make you nervous. Try an opportunity that you're not sure about because you never know what's going to happen. But this program was awesome. So I spent the entire summer there, a month designing the classes, a month teaching the classes. I got to work with some amazing high school girls, and we did all sorts of fun science experiments. We super cooled magnets and floated other magnets on top of them. We taught them how to use drill presses and drilled PVC pipe to make flutes. This is Alice Quillen. She's helping them make some flutes. So basically, we did all different types of physics and just got them ready for high school. And we did it in a very fun way, right? We didn't make them do math problems all day. It was all hands-on experimentation to show them that science really is a good path that they can take and really fun to do. So this is what really got me thinking, maybe I want to be a teacher, an educator in some way as I go through my career. So I did continue on to graduate school over at RIT, Rochester Institute of Technology, just down the road from the U of R. My PhD was technically in astrophysical sciences and technology, basically an astrophysics degree. And one of the reasons that I picked RIT, aside from it being, again, local, I wanted to stay local, was because the program was very astrophysics based, and I knew I wanted to do astronomy. Most graduate programs are physics programs, and then you still do research in astronomy, But this one was pretty much all astrophysics classes, applied physics to astronomy. And that's what was best for me, and I knew I wanted to do that, so it worked out really well. I worked with my advisor, Joel Kastner, on young stars and planet formation, which I'll tell you a little bit about in a moment. But I got a lot of amazing opportunities. So if you're thinking about graduate school, definitely talk to some of the students and ask them what opportunities they have had. I didn't know that I was going to get to go to Kitt Peak twice and use this big telescope, which, by the way, is slightly smaller than the telescope we have here, so just keep that in mind. Our telescope is better. But this one was at Kitt Peak. I got to go twice throughout my career, take pictures of all sorts of cool stuff. I got to fly on Sophia, which was amazing. This actually happened a year after I got my PhD because the government shut down during the week I was scheduled to fly the first time. But eventually I still got to go, so I can tell you that story in a whole other talk sometime. But all of these experiments, again, helped solidify that I loved astronomy, and I wanted to teach people how to do all these practical things, how to use telescopes, how to, not how to fly in the airplane, because I didn't have to fly the airplane, but like how to apply to these professional observatories and get to utilize the data. All of that was really, really fun to me, and I'm so glad that I got those opportunities. So hopefully, if grad school is right for you, you will have some amazing opportunities like this as well. So I'm going to take a few minutes and kind of interlude and just talk about my research so that you can hear a little bit more about that. And then we'll come back to my career in astronomy education. When I was going through grad school, and really still now, there were a lot of big picture questions that we wanted to answer in the realm of star and planet formation. First, we wanted to know more about how stars and planets form. What is the process? What is the timeline? When and where are they forming in the galaxy? Things like that. And then how did our solar system specifically come to be? How do we form a planetary system similar to our own, specifically focusing on the size and scale of our planetary system? Not the big ones, but squishing 8 planets into the small space of our solar system. So to answer these questions, we had to look at star-forming regions. The Orion Nebula is one great example of that, a nice cloud of gas and dust that's actively forming stars. And if possible, this is just a cartoon, but we wanted to look at young stars and resolve as much detail as possible to try and see planets actively forming and understand the process a little bit better. So to do that, we had to use some very specialized telescopes to see star formation at different times, because all of this, from going from a giant molecular cloud down to a star with planets, takes a long time. It takes 10 to 100 million years. So we weren't going to be able to watch the whole process happen once, but we are able to see it at different phases and gather some information at each step. So for those of you that haven't taken much astronomy yet, just a quick reminder about how this happens. You start with a giant cloud, a cold cloud of hydrogen gas. Pieces of the cloud gravitationally collapse. They start to form a young star. We call this a protostar. And then because of conservation of momentum, when you have a rapidly rotating object, some of the material is going to move outwards and flatten into a disk. This slows the rotation of the young star so that it doesn't spin so fast that it rips apart. And it also provides a protoplanetary disk for stars to form in. So as time goes by, the planets are going to coagulate out of the material that's in the disk and ultimately form a young sun with maybe multiple planets orbiting around it. So depending on which phase we're interested in, we could look at stars at this phase or this phase and try and figure out step by step exactly how all of this works. One of the cool things that happened when I was in grad school is we finally got the technology to see, and I'll go back one, basically this to this transition. If there was another position here kind of halfway in between, our technology was at the point where we could actually look at a protoplanetary disk and we could see evidence of star and planet formation. So I'm going to show you the classical HL tau image. This cartoon tells you the appropriate response after I show you this image, because every protoplanetary talk has to show this picture, and your response should be all hail HL tau. You going to say it with me? Here's the picture. Your response? All hail. Yes. Amen. Okay, now we can keep going. So literally, this picture came out in 2014 when I was in grad school, and it is like the picture. And what you are seeing here, this is an ALMA image, Atacama Large Millimeter Array. It is a radio image of a young star, which is buried in the yellow blob somewhere. It's smaller than what we can see in the picture. This is a large protoplanetary disk, and each of the dark orange spaces are places where a planet is forming. A planet is gathering up material. It's orbiting around the young star, and as it orbits around the star, it gathers up more material, and it carves out rings in the disk. So this was the very first, most amazing image that came out. And just for reference, because there's no scale bar on this image, the radius of this disk is about 200 astronomical units, so 400 from side to side. Our solar system out to Pluto is only about 40 AU. So our solar system is far smaller than this. And we can do a little comparison here. Here's the same HL Tau image. Here's our horribly not to scale solar system. It would fit in about that much space on the disk. So HL Tau is amazing. I'm not trying to knock it at all, but it doesn't show planet formation on solar system scales. It shows planets here and here and here and maybe even out here at scales much bigger than our solar system. So then our question is, can we take pictures of young stars that are forming planets on scales of our solar system? And the answer to that is yes. At least at that time, we had finally gotten to the point where we could do that. Literally, the technology had just come out to have that, to be that capable. So one of the stars that we looked at, I'm just going to show you one, is called TW Hydra. This is the closest star, and this is a cartoon, not a real picture. But this is the closest young star with a protoplanetary disk around it. It's just a little bit smaller than our sun. It's a K-type star, so a little bit cooler, a little bit less massive. But being close by, 176 light years away, means that our telescopes will get really good resolution, right? If you're closer to the object, then when you observe the object, you're going to be able to see more detail. It's going to be higher resolution. So looking at the closest young star gets you the best images. This system is only 8 million years old, so literally it's baby. It's just starting to form the planets. And tons of work had already been done on this system. We knew there was this protoplanetary disk, and it had been studied in a million different wavelengths. We knew the composition, the structure, all of that, but we had never yet seen evidence for the planets actually forming. So what I was able to do was take pictures with something called the Gemini Planet Imager. This instrument came out, I think it was 2013, maybe 2014. We got some time, first light time, basically. We got to take one of the first sets of images with this instrument. And it's on Gemini North. Here are some pictures of Gemini and the instruments. I didn't get to go to Hawaii, unfortunately. It's one thing I missed out on. But here's Gemini North. Here's what the actual telescope looks like. It's huge. It's an 8-meter telescope. And then this whole box, that's the Gemini Planet Imager buried inside of that box there. But with this telescope and this high-quality camera, for TW Hydra, our resolution would be 1.5 AU per pixel, which is pretty freaking amazing. That's basically like every pixel, one Earth-Sun distance. So we got really high-resolution data for this star. So what we proposed to do was take pictures at near-infrared wavelengths and look at polarized light scattered off of dust grains in the disk. That would give us the clearest image of the structure of the disk. And if there were gaps in the disk, there wouldn't be any dust there. The dust would have stuck to the planets, and there wouldn't be any light scattering off of that region. So we should be able to see kind of some dark rings similar to the ALMA picture if planets were forming in this disk. Here are our results, and some of you saw this when I gave a talk a couple years ago, but these are J and K bands, so these are near-infrared pictures. The image on the left, this is total polarized intensity, so basically the total light we are seeing. And one thing that you notice is that closer to the star, it's brighter, and the farther away you go, it's fainter. And a lot of that just has to do with the fact that light spreads out as 1 over r squared. So we would expect the edges to be fainter than the center. So what we do on the right side is we multiply the intensity by radius squared, and that basically equalizes everything. We say, okay, if light didn't fall off as 1 over r squared, then we would get an even brightness across the disk, except for places where there was less dust to see, less dust to scatter the light. So what you see, and it doesn't project super great here, but you'll have to trust me a little bit. There were some gaps, especially if you look at the polarized intensity. So darker orange is less light, brighter orange is more light. There is kind of a depression very close to the center circle. There's also a bit of a depression out here. So this is less than 10 AU, very close to the star. This is out here at about 22, 23 AU. And by the way, the dark circles are a coronagraph, so we are blocking out the light from the central star because we don't care about the star, and that allows us just to see light scattered off of the disk a bit better. So our images show that there's maybe a planet close to the star, maybe a planet a little bit further out. There was a known gap out at 80 AU, farther away than our pictures would allow us to see, so it's suggesting at least 3 planets forming in this system, which is pretty cool. Nobody had seen the system at this resolution at that time. So my images got published, we talked about it a bit, and they really paved the way for some of our colleagues to get ULMA data and take pictures like you just saw for HL Tau, but with even better resolution. So this is my picture, and this is the ULMA picture from one of my colleagues. And it's by far better than what we were capable of getting. But same idea as we saw with HL Tau. We're seeing microwave wavelength light. That's now illuminated from the disk. The dust just emits at those wavelengths. And you can see a gap here. You can see a gap here. And this inset is a different image that focused on very close to the star. That dark ring you see in the middle is about 1 AU wide. So there's literally a planet forming in this system, likely at the same distance Earth is from our sun. So my images really paved the way for stuff like this. Ultimately, between all of us, we were able to show that there's a planet at 1, 22, 37, and 43 AU. We already knew about a planet at 80 AU, so this system is up to 1, 2, 3, 4, 5 exoplanets. And maybe more. We still have to study the edges of the disk a little bit better. So at the time, 2015, 2016, this was cutting edge. And now that we're up to 2021, it's commonplace. Here's 20 recent images from ULMA, all of young stellar systems with really distinct gaps in some of these disks. It's just amazing the pictures that we can take. So technology has continued to improve, and we're going to get a lot more pictures like this, and hopefully a lot finer detail, maybe even be able soon to see the individual planets if they exist inside the gaps of these disks. All right, any questions about that? I should pause and see if you have questions. Yeah?
There's one in there that's really at an angle. You're looking at it more edge on.
Yes, these ones, for example.
And can you see gaps in that one too?
So probably not. There's maybe a little bit kind of towards the center, but the coloring still suggests that there may be gaps in the disk. So you can look very precisely at the depressions. Definitely not as obvious as, say, the ones that are face on, for sure. Awesome. So I got to do a whole bunch of different projects just to show you the breadth of things that you can study in the realm of young stars and exoplanets. We took a look at another star called V4046 Sagittarius. My 360 students will recognize it from their last homework. But this is a variable star with a disk around it. We took some Spitzer data of it, and we looked for emission features of different materials. It tells you what the disk is made of, and it also tells you a little bit about accretion. Neon 2 actually comes from shocks, where the material is accreting onto the young star, and you are getting shocks, and that ignites emission from neon 2. So we were able to take a look at the components. We were also able to model the structure. So if you modeled the shape of the curve here, you can figure out the sizes of the dust grains in the disk, because the bigger the dust grain, the more they're going to emit at longer infrared wavelengths. So we were able to show, what is the percentage of different types of material, how big are the dust grains, how old is this system. And we also took some pictures with Gemini of it too. This one is not as crystal clear that there are gaps, but there's definitely evidence for some inner gaps, and then maybe one kind of right here as well. And those of you that were here last year, you met Hannah. She's the one who interned with me after graduate school and took a look at some young stars in the Orion constellation. And we basically, this is the picture from Sophia. I don't remember if she showed it, but we were looking at 1, 2, 3, 4, 5 young stars. And with the Sophia data, we actually resolved these 3 stars for the first time. In other telescopes, they were just one big blob, but now we could see 3. And the star in the middle there is actually a binary star. You can't tell in this picture, but in other images, you can tell that there's actually a 4th star there. So she did some work identifying young stars, figuring out the ages of these stars. That's not her corgi, but his name is Dipper. He's a friend's corgi, because all of us astronomers name our pets after nerdy things, because that's what we do. So that's Hannah, and that's Dipper. So studying young stars, I think is fascinating. If anybody wants to, think more about this work, we can definitely talk about it and do some projects. But let's transition back to the reason that we're here and talking more about science education. As I went through graduate school, I loved my research, but I also really enjoyed the outreach and the teaching. So as I went through, I had the opportunity to try out a whole bunch of different things. I got to teach K-12 science camps. So show young girls how to look through telescopes, build dry ice comets with a little camp of kids there. I also did some lifelong learning teaching, which is teaching to older adults, often at senior communities. So here's a group from Webster, New York that would come and see me once a month, and we talk astronomy. I did some work at the Strastenberg Planetarium. They have a star ball projector from the 1960s. Its name is Carl. It's a 70-foot dome, so it's bigger than our planetarium. Now they have actually upgraded to the same system that we have. They have a Digistar 2, and it's amazing there now. It's really cool. But I got to operate the planetarium. And I also ran something called Imagine RIT, which is where all the students on RIT's campus got together and had a festival where they presented their research, but in a really fun way. Like, it wasn't just poster sessions. It was show me your research, but let the public come and do some activities with you to understand what's happening. So this one was really cool. It was called Marvels of the Universe. We took ourselves, and one of the students here, Marcus, he's a really good sketch artist. So he turned us all into cartoons, like Marvel characters, and then we made comic strips of our research with us as cartoon characters. It was super cool. And we walked the kids through it. It was a lot of fun. We should totally do something like that here. But yeah, so basically anything to reach out to the community was a lot of fun for me. And I knew by the time I finished my undergrad career, my graduate career, that I wasn't all about this hardcore research. Like, I loved it. I really do like studying young stars. But there's a lot of background stuff that happens when you go and become a professor. You got to fight for your funding. Time on large telescopes is getting more and more scarce. It's harder and harder to get time. If you don't get time, you don't get money, then you don't get tenure and you don't have a job. It's not fun. If that's not what you're dedicated to, it can be a really, really rough time. So I was just not down for it. I knew I wanted to focus on education in some form or another. I didn't want to go to one of the fancy research institutions and spend all my time doing research. I wanted to focus on education. Excuse me. So where did that leave me? Well, my first job after graduate school, as Dr. Gallagher mentioned, was at the Dudley Observatory. My job title changed multiple times while I was there, but I started out as what they called the outreach astronomer. This was over in Schenectady, New York. And when I got the job, I had never heard of the Dudley Observatory before. And it was only after I got the job that I realized how famous this institution is in the history of astronomy. And I wish I had known more about it. So the Dudley is the oldest independent astronomy research organization in all of the United States. It was chartered in 1852, and it actually started the Astronomical Journal. Benjamin Gould, the original director, whom 360 students also learned about today, he started the Astronomical Journal, which we still publish in as professional astronomers today. The Dudley also made some of the first star catalogs. They had a Meridian telescope, as well as this. It's called the Prime Refractor, 12-inch refracting telescope, so it's about 10 feet long, 12 inches wide, and it catalogs stars in the northern hemisphere, so they have giant books of them. And Dudley was actually the organization that was the largest employer of women in the sciences in the early 1900s. So we talk about the Harvard computers and astronomy all the time, but it was actually the Dudley that had more female computers than Harvard earlier on in the 19th century. They had won some grants and hired a bunch of women to help them out. So they're a much more famous organization, and I should have known about them, but embarrassingly, I didn't know anything until I got the job there. But my job was not really to focus on the history of Dudley. My job was to move it forward, not as a research or historical institution, but as a cutting-edge educational institution. So my job was basically to design, coordinate, and teach a whole bunch of different astronomy activities to anyone who would sit and listen to me, kids, adults, whoever. And to do this, they actually partnered with the Science Museum, MySci, and I know Hadley has some experience there at the planetarium. But they partnered up with the Science Center, and that's actually where my office was for most of my time there. And we worked with the Science Center to do science for everybody. We did solar observing for adults. Girl Scouts come in and make models of the Big Dipper. And part of my job, too, was not just to design curriculum and teach, but it was also to communicate science with the public. So be the face of the Dudley Observatory. Share what we're doing, talk about how amazing astronomy is. So I had the opportunity to go on radio shows and TV. This is me with Neil Estano, the meteorologist at the local TV station in Albany. We used to do a stint on Sunday mornings. I get up and go at 6:30 in the morning to the news station, and we talk about whatever's happening in the sky that month, and it was just a lot of fun. So I'll show you and then just talk about some of the programs we did briefly to give you a sense of what this kind of nonprofit museum educational job looks like. Primarily, it's working with kids. So if you're interested in this, you got to be comfortable working with kids. But there is some adult work too. So we organized some lectures. This is at a place called the Octagon Barn. It's out near Delancey, New York, middle of nowhere. It is literally a barn shaped like an octagon that we got together and talked astronomy in. So we'd have big lectures there. People from the public would come and enjoy them. We also, there was a planetarium, similar in size to the one we have here. Not as fancy, not digital, it just had a star ball there. So I got to operate the planetarium, run some planetarium shows, and lots and lots of stuff with kids. We had a star lab. This is literally an inflatable planetarium that you cart in your car to schools. You blow it up with a giant fan, the kids crawl inside and they look at the stars for half an hour. Tons of fun, a lot of work, but tons of fun. I was never as strong as I was when I had to cart Star Lab around every spring. It's very, very heavy. We also did some work with real little kids. So we did some pre-K programs. This is a little boy. He just built a little moon rover that has some marshmallow astronauts in it that he's trying to launch into the sky. We did some teenage programs where we bought a bunch of teenage interns the Dobsonian-style telescopes. We taught them how to use them. And then finally, we did a lot of festival stuff. So this is me with a solar telescope letting a little girl see the sun for the first time. This was also the day where the festival put the face painting booth across from the telescope, and I could have murdered them because it was just, I spent an hour and a half with a Q-tip getting face paint out of the eyepiece of that telescope at the end of this day. It was just awful. But stuff happens, the kids had fun, and that's really all that matters. So this is the kind of stuff that I loved doing. Designing the curriculum, teaching the programs, and getting out there in the community and just showing them how amazing astronomy is. Because it is, it's fun, it's amazing, and people should know more about what's going on. The one other cool thing we got to do in 2018 is we built a new observatory. So this is the observatory building. It's a roll top roof building where you push a button and the roof literally rolls off onto the banisters there. And the telescope inside was a 14-inch Celestron, so pretty much identical to what we have down at College Camp, the Celestron, the 14-inch there. And we intended to use it for public observing nights, not necessarily for research, although we were going to do that, but it was really more to bring the public in, to make some money for the museum, and let them look at the stars and have fun. We also got to cut the ribbon. I got to use the giant scissors, which was a lot of fun. And, you know, stand with the politicians and everything. That's Angelo Santa Barbara, one of the politicians out there. So, you know, just trying to get the face of the deadly out there and do all this fun stuff. So this was a lot of fun. We built this, but unfortunately, we didn't get to use it very much because things kind of started to tumble downhill after this. So by the time 2019 rolled around, there was a new director over at my side, and she just wasn't all that thrilled with astronomy. Not in the same way as the previous directors were. She was very focused on building exhibits. She was not an astronomer. I think she was an anthropologist, if I remember correctly. So totally into science, but not into, she didn't really appreciate the observatory, the planetarium, and all the potential that was there. And we also, you know, like all nonprofits, struggled with funding. If you ever work in a nonprofit, you'll realize that they never have enough money to do what they want to do. And funding was, you know, getting lower. It was hard to get money from the community to do the things we wanted to do. So ultimately, this led to the Dudley Observatory taking all their stuff, literally packing it all up, and moving to a different location because the museum essentially said, we don't want to have this partnership anymore, which was really unfortunate. And this is about the time when I knew that I had to start looking for a new job because my funding wasn't really secure. I was getting funded through the Dudley Observatory, which had an endowment, so my salary was a little bit more secure than some of the other people at the museum. But I was really just going on the word of the board of the directors that they were going to pay me and hoping that that was actually true moving forward. So I wanted something more secure, but still in the realm of science education. So where do we go after this? Well, we had a bunch of historic stuff, and if you're interested in going to see it, we actually donated it all to the New York State Museum, and they were going to put up an exhibit sometime in the next couple of years about all of the cool astronomy history in the area, so hopefully we'll be able to check that out. And in October, we packed up my office, and we moved over to Siena College, in part because one of our board members is a professor there. And he talked Siena into letting me have an office there for a little while, in part because Siena just recently built a new observatory with a 27.5-inch plane wave telescope. So they have the largest research-grade astronomy telescope in the state that is permanently mounted, like it doesn't move. Ours is bigger, but it's on wheels. So they're claiming that theirs is the biggest because it's in a dome and it's still, but ours is technically bigger and better. So we lived in Siena for a little while. I worked on trying to get an official partnership with Siena College, but it got really complicated. So you can imagine, you know, leaving the museum and the structure of a nonprofit and having people to help you meant that I now had to do everything. So I got promoted to director, which was awesome. It means I got paid a little bit more money, but I had to do everything. I basically had to run a small business, which is not really what I wanted to do with my life. I wanted to teach astronomy, but instead I was marketing the programs, booking the programs, teaching the programs, invoicing and paying the bills, calling the schools and begging them to pay their bills so that I could get paid money, managing the board of directors, managing the website, dealing with all the people that tried to hack our website and put nasty things on it, negotiating the Siena partnership. It was just a laundry list of things to do. And honestly, it was too much. You know, it was consuming way too much of my life. The salary was great, but it wasn't really worth it. It wasn't clear that Siena and the partnership were going to work very well together. And, you know, COVID came shortly after this, so this wasn't even during COVID times yet, but that has complicated things. And to my knowledge, Dudley and Siena still don't have an official partnership to this day. I know they've progressed forward a little bit on it, but basically things were they were really rough. And as I mentioned already, funding for my position was uncertain. I was going on other people's words that I would get a paycheck every month, and that didn't make me feel very good, right? I wanted the job security. And as I said a million times, I want to teach. I want to do the fun stuff. When there's an eclipse, I want to be in front of the TV camera showing them the eclipse. I want to teach the kids, and I want to get thank you notes like this. I want the kids to have fun. Apparently, this kid thought there was 3 suns that day, and my eyelashes were amazing. I love pictures like this. It makes me happy. Like, this is what makes me happy. None of this makes me happy. This is what makes me happy. So I kind of had that realization that, I needed to go somewhere where I could do the teaching, and not just outreach teaching, like, teaching at the college is just as rewarding for me as all of this stuff. So I looked at a whole bunch of different jobs, and I considered many different career paths over the last year, a little bit longer than a year ago now. So I looked at industry jobs. GE is big around this area, so I wanted to stay in New York, preferably in this area. So I looked at industries like that. I looked at different colleges, other museums across the state. And as you all know, I ultimately ended up here, which I absolutely love. And why did I end up coming here? It wasn't just because they offered me a job. It was because that I felt I fit in here. We have amazing equipment that I get to use, and I get to work with all of you and teach you how to use it, let you do amazing things with this equipment. Oneonta is a teaching-focused college. We still do research, but I get to spend most of my time teaching and thinking about how I can better my teaching, and that's what I wanted to do. And we also value community outreach a lot. We have the Science Discovery Center. When I came here and talked to the students and talked to the faculty, they were excited about all of my history and all of my experience. At other colleges, that would not have been the case. A lot of colleges that are big on research would have looked down on me and said, why did you waste 5 years playing around with kids? You could have been doing research. That's their attitude. But here, that's not the case. You all appreciated what I did, and you're going to allow me to keep doing it, which is really awesome. So I don't know, am I talking too long? Let me summarize some of the projects here, and then I'll be finished. So I wanted to share with you what I'm doing now, because I want you all to know that you can get involved with any projects with me. And whether you think you want to do astronomy education or not, there's still opportunities. So what am I doing now? Well, we're getting the observatory up and running. Joseph helped, and I think Daniel's online. So they were working on the observatory over the summer. Here's some fun pictures of us. Basically, the observatory is slowly getting up and ready for all of you to use it. The 14-inch, after tonight when we finish polar aligning it, will be ready to go. The other telescopes are almost there. So lots of scientific research projects to come. We also have done some planetarium work. This was all the virtual stuff we did over the summer. Cole Johnson helped with that. So this is a little screenshot of us presenting to some of the community using Stellarium, which we're still going to do that. I think this Friday is my first show online for the public. So if you guys are interested in helping with the telescopes or doing planetarium shows, you can let I or Dr. Nolenberg know. We're happy to teach you how to do that. I'm also trying to continue some of my science communication work. Some of this is things I'm doing myself, but if you're interested in this, I'm happy to let you shadow, and if there's any opportunities where you can help me participate, I'm more than happy to have you come along. But I do some online teaching through a company called Streamable Learning, which basically reaches out to K-12 students across all of North America. And I just get to teach astronomy a couple hours a month to all of these kids, which is great. I do a radio show down in Albany with Bob Berman. I don't know if you guys know Bob Berman. He's a very famous astronomer, editor of the Old Farmer's Almanac. He's been doing the radio show for like 30 years. And they invited me a couple of years ago to come join him. So we tag teamed this call-in radio show and answer people's crazy questions about astronomy. And I recently got contracted by the Great Courses, which rebranded as Wondrium, to design a class on observational astronomy. So it's going to be very similar to Astro 360, but designed a little bit more for the general public and how anybody with a telescope and a camera can contribute to real science. So this will be really cool. I'll be writing the series over the next 2 years and then filming it all in one shot. It's going to be a crazy week. And then it'll be out for the public to view after that. So this kind of stuff is a lot of fun. If you ever want to go with me to the radio show, you can sit with us and listen. It's really cool. And then public outreach stuff, we're still working on that. So Cole is actually continuing with me this semester. We have designed a class for the Saturday enrichment program. So for 3 hours every Saturday for a month, we're bringing some 3rd to 5th graders in and we're doing astronomy activities with them. If you want to volunteer and help, let me know. You don't have to like physically teach or run anything. You just kind of need to be a helpful hand in the classroom. And Doug Riley and I from the Science Discovery Center just got a small grant to design some curriculum for 4-H youth that will utilize these Earth and Space toolkits that we already have here, but kind of just piece them together in a way that makes sense for students that want to study nature and kind of, everything that 4-H does. So focus on rural youth and how they can make their own astronomy observations and do some science within their area. So we're going to be working on that probably next summer a little bit. So if you want to help with that, let me know. And yeah, so I'm going to wrap up here by just kind of saying, if you're thinking about a career in science education or science communication in general, there's a lot of different professions you can do. Obviously, you can become a teacher or a professor, a K-12 teacher or a teacher at any level. You can go work at a museum as a planetarium operator, a museum professional. You can be an administrator if you really want to. I don't recommend it, but if that's your thing, that's your thing. We also desperately need science writers and science journalists. I mean, think about all of the science articles you've read from mainstream media and how they're either terrible or lacking information or totally misinterpreting the science. We need people that know science to help write these articles. So that's a really cool career. I can hook you up with some science writers that I know that write for magazines, get you some experience there. That would be cool. So lots of different job opportunities. And if you want to have this career, here are some things that you can do to prepare. So first, practice your presentation and public speaking skills. Get used to standing up in front of other people, kids and adults, and talking about whatever interests you. This could be through a class, conference, and it's also good to attend talks like this and other talks and take notes about good or bad presentations, right? I'm not perfect, so take notes about everything you think I did wrong and how I can improve. Take notes about things that were good and use them when you present to kind of learn those skills. Volunteer, work with me, work with any of the faculty here. Even if they're not astronomy education projects, you're still going to get many of these skills from doing a project, presenting the project, and also connect with all the clubs here, right? The Nebula Society, the Physics Club. There are opportunities for you to do outreach projects or do any kind of project. And get experience working with kids. If you really want to do science education, specifically in the museum world, get in front of some children and learn how to interact with them. Because teaching a college class is very, very different than teaching an 8-year-old about a similar concept. They will ask you the same questions about black holes. I guarantee that some of you have asked me the identical questions that 8-year-olds have asked about black holes. And that's not talking down to the college students at all. It just means that everybody is excited and interested about black holes, but the way I would communicate the information to you is way different than I would communicate it to an 8-year-old. So getting that experience is very helpful. And then finally, know your stuff, right? It's not just about being able to present material, it's being able to present the material confidently. When I go to the radio show, people can call in and ask me anything. And I don't know all the answers, but I have to be, up on all of the current things. I have to know as much physics and astronomy as I can to be able to logically answer their questions. And you also learn some skills about how to dance around the answers when you don't know the answer, but still sound smart when you answer their question. So we can practice some of those skills too. I've learned that over the years. So I will leave this last slide up and just say, I think an astronomy education career is super rewarding. And as I showed you the cute little picture before, it's things like this from young and older students that make me happy. This is why I do my job. It's super rewarding. I want to inspire young people, especially young women, to want to become scientists. And I want to teach college classes where people truly feel that I'm presenting something in an understandable way and inspiring them to learn more. So that's my life. Pretty much everything I've been going through for the last 10 or 15 years and kind of why I decided to go this route. Do you guys have any questions? Yes.
So, one thing I imagine two things strike me about all the speakers we've had. They seize opportunities when they pop up, and they have to negotiate through difficult times, which happens everywhere and with every path. So if you're there, so seize opportunities and don't worry about difficult times.
Yeah, there's always something better behind the next door. There really is.
I imagine networking must be a huge part of, because you're doing an inspiring amount of things. So how big a role has that played in all the different opportunities you've had to seize along the way?
Right, exactly. It really goes along with, seize all those opportunities. So if you get to meet somebody who is doing something at another museum or planetarium, if there's any way that you can offer to help them, even in a little capacity, that's really great. One thing I didn't mention is that I had met some people that work at the Astronomical Society of the Pacific, and they were doing a program during COVID about how to teach better online. And I just did like a little thing with them where I presented something. And then all of a sudden I've made all these new friends. I'm being asked to do other things, log in and give talks to colleges all over the place. So as we've said, seize all those opportunities and talk to as many people as you can. Inquire about their career paths and what their projects are. And even if you just show a little bit of initiative to ask about it, they're going to remember you more than they're going to remember somebody who just, waved hello to them at a conference. They're going to remember that you asked and were interested, and then they might ask you to do something and help them out later. So network as much as possible. And share your ambitions with other people too, by the way. That's one thing, is don't be shy about telling everybody what you think you want to do with your life, because that's going to help you open doors and make connections that you didn't even know were possible. Did you have a question? Did I see hands up? Any questions online? I didn't check online.
Yeah, I should have been up there helping you with that.
No, it's okay. They're silent online, that's all right. Anybody online can stick questions in the chat box or just unmute. We can hear you here.
Well, if they don't want to, I do.
Sure, go for it.
Spitzer, what is Spitzer's, what is the Spitzer telescope?
Yeah, the Spitzer Space Telescope was operational from 2004 till about 2018, give or take. It's a couple meter telescope, purely near to mid-infrared. So it had a couple of instruments on it that did near infrared, a couple of microns, a couple of microns. And then it had one longer wavelength instrument that only lasted a shorter amount of time. And it was up in space studying everything from star and planet formation to galaxy collisions. It focused on anything that you could study in the infrared, and it was one of NASA's great observatories. It was the last of the 4 great observatories to launch. So the U of R had been working on it since the 80s, kind of designing the different instruments, testing them out. They have a lot of amazing labs there that allow them to do infrared work and test infrared CCD detectors.
That must be Daniel that just asked a question.
I can read it here. Oh, the next talk with Bob Berman. Good question. It's in my phone. I don't remember. It's October something. Hold on. 21st, October 21st. So I'll try and remember to send out a link to everybody. You can listen online. I found out the other day that the chemistry department streams it, not because of me, but because they listen to NPR. It's through NPR. And then they realized that I was on it one day, so now they specifically turn on the astronomy one. So yeah, it's going to be 2 o'clock on October 21st, the 2 to 3 o'clock hour.
Yeah, I think if you use whatever voice activated thing, Google or whatever, if you say play WSKG, you get Binghamton, but if you say play NPR, you get the WAMC.
Right.
Oh, that's always on Thursdays and always at 2 o'clock?
Generally, not always. Sometimes it's Tuesdays, but it's usually once a month on a Thursday at 2.
What is the strangest questions you have gotten while doing the radio show?
Oh my God. The conspiracy
Or give us
theorists
the
call
top
in.
10.
What's that?
Or give us the top 10. No,
You know, I think some of the strangest stuff, I mean, obviously you get the typical flat earthers. Bob Berman has written books about consciousness in the universe, and that really brings up a lot of, religious talks and ethical talks and stuff. So we get a lot of questions about that I always toss over to Bob. And then we get some bizarre questions where, like, people ask weird things about observations, like, the last question's about the moon phases, but, like, I don't understand how they logically make these inferences. Like, I don't know, they'll see different shapes in the moon and they'll conflate it with the moon phase idea. And so they just kind of ask the strangest questions. I'm trying to think if there was like a really good strange one. A lot of people are quite knowledgeable. I don't mean to make it sound like it's always flat earthers that are calling in. It's a lot of people that are asking, what is the bright light in the sky? But they genuinely want to know, right? And it's a lot of older people who don't have apps on their phone to tell them the answer. So we have to tell them, oh, it's Venus, it's Jupiter. Every seasonal change, we get calls about, why do we have the different seasons and why does the temperature change slightly different from when the autumnal and spring equinox are, kind of stuff like that. I don't know if there's any like one weird question that sticks in my mind that was very bizarre, but we get some conspiracy theorists that come in and, they always challenge you. They always think they know more, and it's hard to knock them down. And the host, Ray Graff, has gotten really good at politely hanging up on people when he's had enough. So I don't have to deal with that as much. He catches it on. Yeah, he does. He does a very good job of saying, that's a great question. Click. Valerie, do you want to answer it? You guys don't hear the click, but I already know that he hung up on the guy, so I'm not going to get it talk back so I can hear whatever I want or say whatever I want. I'm sorry I don't have a good answer for that.
It's sort of it's a gratuitous question.
Yeah.
But how do you deal with misconceptions?
Yeah, it's tough. If depending on the question, sometimes I encourage them to go outside and make their own observations of things. Like there are a variety of different ways that you can kind of observe that the Earth is spherical and not flat just by looking at the shadows that are cast on the moon or paying attention to the motions of objects in the sky and kind of logically going through those steps. The worst thing you can do is, call them crazy or tell them that they're wrong. You definitely don't want to do that. But you just try and encourage them to think more logically, because they usually have read something and instantly believe it, or they observe something, but they have misinterpreted what they observed, the reason that they have, observed something. And you just try and get them to think more logically as much as possible. And some people, there's no hope. They're just calling because they want to probe you and see what you'll say. Many of them want to know if aliens are real, and I don't have the answer. I hope they're real, but I don't have a good answer. But they also seem to think that I know something that the world doesn't know because I'm an astronomer. So they want me to say, oh, the aliens are real, but don't tell anybody. But obviously I can't say that.
Is it hard on the radio without props?
certain things, yes. I mean, in a classroom, we'd get everybody up and we'd show them how the moon doesn't rotate by walking around in circles. You can't do that on the radio. And it's also tricky because you never know what they're going to ask, right? It's not like I can really prep aside from knowing kind of some of the things that have been in the news lately, because usually that kind of stuff comes up. But you really got to be able to switch from moon phases to black holes to exoplanets and the flip of a coin, depending on what they ask. So it's definitely tough. I like the visuals and being able to use my hands and demonstrate things, but it's fun nonetheless.
Anyone else? All right, well, let's thank our speaker. Taking time out of a day that never seems to end, especially if you're an astronomer.
Yes.
I want to thank you all for being here. I think it's good for you. You learn stuff, and actually we had 2 speakers last year who said, go to talks, any talks, go to something. And I know you're online. Daniel De Jesus Minierte asks one question or more at every single talk.
And he's a star.
He was a little late today. I would like all of you, okay, to come to the future ones we're going to have. And when you read the little bio, try to imagine a question you will ask, okay? And then work up the courage, sadly, to ask it.
Yes.
I know, I picked on you, but Josh, okay, so now Josh is here.
I never said the courage was the problem.
I'm sorry, did you ask a question here?
I did not, but.
Okay, just saying, okay? All right,
That's a great
Javon?
I probably have like tons of questions right now. I'll leave and then think of a question.
Yeah, no. Yeah, no, you always think of the question as soon as you
Yeah.
leave the room.
Well, you know where my office is. You can come down, ask me anytime, and I'll tell you whatever you want to know. So
You let me know when they get there.
I will.
Thank you.
Been
I would
to
ask
answer
more about
many questions, but-
industry of astronomy, but you're more into like outreach and teaching education. Because I'm planning on doing a lot more. I probably could ask a bit about how your grad school experience was.
Sure.
I would really love to learn about that.
Yeah. I'm happy to spend time with anybody who wants more details about my life. Why I changed schools originally, what grad school was like for those of you that really do want to do that path, which is a great path to take too. So yeah, just swing by and I'll happily answer.
Thank you, everybody. Thank you.
Take some pumpkin muffins as you go, please. There's a whole nother layer.
Yeah, I was waiting for some other people to get them, but nobody else did, so I was like, okay.
Oh, just eat them. You should never be shy about eating food.
I'm gonna run because I had a soccer game.
Yeah, but
Yeah.
I come back.
I go to a soccer game every day in the fall.
Like, yeah.
Soccer team winner.